And here it is, folks, what you've all been waiting for, the end of chi-squared tests. So this is it. It's not a new test, it's just we're going to practice telling them apart, and we're going to look at an example. All right, so we've got our three different types of chi-squared tests. We have goodness of fit, or GOF as we often call it. All right, does one sample match the claim data is what we're testing here. So we have one sample and we have one factor. All right, the most basic thing, one sample, one factor, goodness of fit. All right, for independence or for association, we have one sample and we want to see if those two factors are associated with each other. Two variables, one sample, two variables, independence or association. All right, and then if we have two or more samples and we're asking about, say, a factor, that's when we do our test for homogeneity. All right, so these are both just done with chi-squared test on your calculator. This one is the chi-squared goodness of fit test. Now, if you aren't sure about the difference between independence and homogeneity, and you just write chi-squared test for the name of the test, most of the time they still give you the points for that. So most of the time you still get points for that, but they do want goodness of fit written if it is a goodness of fit test for sure. So here are three scenarios, one for each. So let's see which one's which. So are NHL players more likely to have birthdays at the start of the year? Researchers randomly sampled NHL players about the month they were born to determine if being born in January or February is more likely than other months. So we randomly sampled NHL players. So we definitely have one sample. And the only thing we asked them about is when they were born. So one factor. So one sample and one factor, hey, that's goodness of fit. So this would be a chi-squared goodness of fit test. All right, and then we would go about doing the test from there. Let's look at the next example. Is the quality of life better in Canada or the US? I think I already know where this is going. Researchers compared random samples of US and Canadian heart attack survivors and asked about the quality of their life since they had a heart attack. So we have random samples, plural. So we have two samples. And then we asked about one factor, the quality of their life. All right, well, two samples tells us that this is the test for homogeneity. All right, we're looking for the sameness. Are the answers the same in the US and Canada, or are the answers different in US and Canada? So we're testing sameness, homogeneity. All right, next one. Are men and women equally likely to suffer lingering fear from watching scary movies as children? Researchers asked a random sample of 350 college students about their exposure to scary movies before the age of 13. The results are broken down by gender. All right, so we're asking them about the scary movies, and we're asking them about their gender. So we're asking them about two things, and it was definitely one sample. And now we're looking at two factors. And now we're asking, are those two factors associated with each other? So this is a test for association. I'm just going to draw a line. Chi-squared test for association. All right, because we had one sample and two things that we were asking them about their exposure to scary movies before age 13 and their gender. All right, so here's an example. In a random sample of high school students in Oakland, researchers asked how they get to school and what grade level they are in. The two-way table summarizes the results. Do the data provide convincing evidence of an association between grade level and method of transportation to school? Okay, so let's see. We have a random sample. So one sample. All right, and we have multiple rows, so we have multiple factors, it's a two-way table, right? So we have multiple factors. In fact, we have two factors, how they get to school or grade level. So two factors. Grade versus transportation. All right, so since it's one sample and two factors, that means this is the chi-squared test for association or independence. All right, we want to see if grade level and transportation method are related to each other some way. That wasn't straight at all. It doesn't matter. Our no hypothesis, no, so there is no difference, or there is no association, so we're doing the association test. association between grade level and transportation method. All right, so they're not related, is our null hypothesis. Our alternative hypothesis is there is an association. There is an association between grade level and transportation method. All right, and they didn't give us an alpha value, so we'll go ahead and go with 0.05 again. All right, we're going to test here. So this is the test. I've already written it down. I had to figure that out right from the beginning, so I just wrote it down over here right from the beginning. And the first condition is that we need a random sample. And it is stated, random sample, right there, underlined. Next, our expected counts need to be greater than or equal to 5. I'm just going to leave that there. We've got to remember to come back to it. And independence. All right, our N here is 480 people. Hopefully that is less than 10% of all Oakland high school students. So not necessarily just Oakland High School, but all high school students in Oakland, all right, in Oakland, so not just Oakland High School. All right, so we're going to our calculator. The chi-squared test for association is just chi-squared test. We need to remember to put in the matrix. So let's see. There's our calculator on. So second, x to the negative 1 to get to matrix. We're going to edit. I'm going to move this over here. And we've got 1, 2, 3, 1, 2, 3, 4. So I don't remember which way is which, but let's try 4. Yep, that gets us 4 up and down. That works. And 3, not 23, 3. And now we need to put in these numbers. So going across, we've got 50, 40, 30. And then we've got 60, 30, 20. 60, 30, 20. And then we've got 45, 30, 50. 45, 30, 50. And then 35, 50, 40. 35, 50, 40. I may have to make my expected value matrix a little bit bigger because this is a big one. All right, so 4 by 3. All right, so now we're going to get out of here and we're going to go to stat. You probably just press stat and that would work too. We're going to chi-squared test, so it's easier if we just go up. There it is, option C. And we put our stuff, our observed was in A. It will automatically calculate B for us. And there we go. So our chi-squared value is 27.5. Pretty big. Our p-value was small. All right, there was an e at the end of that. So it was 1.15 times 10 to the negative 4th. So that means we'd have 3 zeros in front of that. And our degrees of freedom, let's see, we had 1, 2, 3 by 1, 2, 3, 4. So that's 4 minus 1 times 3 minus 1. So that's 3 times 2 is 6. And that calculator should have also given us that. There it is, 6. The reason why I keep calculating this is sometimes there's multiple choice questions that just ask you to calculate the degrees of freedom. And you just got to be able to do, okay, 1, 2, 3, 4, 1, 2, 3, 4 minus 1 times 3 minus 1, 6. Done. Easy. All right, let's go back and look at our expected values before I do my conclusion here. So let's see, second matrix, edit. Notice that matrix B has now changed to a 4 by 3. And there are our expected counts. We don't need to write out all the decimals. So 47.5, 37.5, 35. Oh boy, need more room here. So let's just go 47.5, 37.5, and 35. Yep. All right. And the next row was 43.5, 34.4, and 32.1. I'm not going to remember any of those. 43.5. It's going to know 34.4 is what that rounds to. And 32.1 is what that rounds to. All right, next, 49.5. 39.1 and 36.5. All right, the next row is exactly the same because they have the same row total here. So it's 49.5, 39.1, and 36.5. All of those are greater than or equal to 5. That checks out. And these are our expected counts. Aha, I remembered. All right, so now since our p-value is minuscule, equals 1.15 times 10 to the negative fourth is less than 0.05, which is our alpha, we reject. Our p is low. That means we have significant evidence for the alternative. So we have significant evidence that there is, or for, an association between grade level and transportation method. I suppose you could say transportation method to school, or how you get to school, something like that. Any of those will work. And that's it. All right, so this right here, I believe, was the end of chi-squared. So yep, there it is. That is it for chi-squared. So check out the Google Classroom for the homework for chi-squared.